Okay, welcome to the class, and we will see the restrictions on CORESET design such for blind decoding, okay, such that a UE can satisfy this constraint that it has to figure out whether a UE, whether its DCI has been transmitted or not within the maximum attempts which are allowed. Okay. Right. So, we will see how this CORESETs are designed with certain restrictions to enable this that maximum number of attempt constraint. Okay. Right. So, that is what we are going to discuss, and we will recap what we have studied. So, two different kind of CC to REG mapping, that is what we saw. UE moves slowly and its MCS is reliable, it will be used non-interleaved mapping, base station will use non-interleaved mapping, otherwise it will use interleaved mapping. Right, okay, and this is typically how the CORESETs are defined, and we saw this in the last slide that this is non-interleaved mapping, this is interleaved mapping, okay, right, and the mapping use the idea of REG bundle, okay. So, REG bundle set of REGs for which the device can assume the channel is constant, okay, right. So, REG bundle size for non-interleaved mapping is 6. Fine, okay. For interleaved mapping, if it is 2 symbol CORESET, it is either 2 or 6. Okay, 2 we showed that this is basically if it is even if it is 1 symbol CORESET, okay. So, it is like we have shown it for 2, okay, right. For 2 symbol CORESET, it is 2 or 6, okay, correct. And for interleaved mapping of 3 symbol CORESET is either 3 or 6, okay, right. So, finally what we said was that each CORESET can either have interleaved mapping or non-interleaved mapping, but not both, okay, right. So, let us continue our discussion from here, and what are we saying here, okay. And I gave you an example also, okay, that wherein UE monitors these CORESET at multiple aggregation level, okay, for PDCCH candidate detection. Okay, what did we say? We took an example wherein the aggregation levels of 1, 4 and 8 were defined for 2 different UEs, right, okay, and it was searching for this PDCCH candidate. It is a candidate because like only if it is like candidate is what? Is like it is a potential place where the DCI can come, okay, right. So, at aggregation level, for example, at aggregation level 1, user 1 DCI was not even coming, right, okay. So, that is why we call that as a candidate, okay. And if its SNR may fluctuate if it moves, right. So, typically what standard says is, since the SNR can fluctuate if it moves, so what it is supposed to be doing is, it is supposed to monitor 4 different DCIs which can come in multiple CORESETs, okay. So, in the last example, we only sent 1 DCI at 1 aggregation level, okay, but the DCIs can come at multiple aggregation level for the same user, okay, and that can also happen. And why? Because there are different kind of DCIs. One is for, just for example, one is for downlink scheduling, other one is for uplink scheduling, okay, grant. There are others also, okay, right. So, other DCIs for doing some other tasks can also come, okay. So, UE monitors up to 4 different DCIs. That is what that is the point I am trying to make here, okay, right. And it can come in multiple CORESET and multiple aggregation level. Like for the downlink, it can come at aggregation level 1, at the uplink, it can come at any other aggregation level, because as I said earlier sometime, that downlink and uplink power budgets are different, okay. So, UE might see a different SNR in downlink, okay, and some other SNR in uplink, okay. So, different SNRs in downlink and uplink because the transmit powers are different, okay, right. So, you can use one aggregation level for downlink, other aggregation level for uplink, okay. So, and not that the same CORESET can have CCs with multiple aggregation levels. That is what we just said, okay. So, it can have CCs with multiple aggregation level, and I will show you what. That is how this CORESETs are defined for this particular user, okay. So, this is basically, you can take this as the OFDM symbol, okay, along frequency axis, okay. This is one OFDM symbol, okay, the same OFDM symbol, okay, right. And the way we are defining here is this PDCCH candidate with aggregation level 1, Where can it begin? It can begin at any place, 0, 1, 2, 4, 3, 4, because it's aggregation level 1. And what am I showing over here? What is this? This is 1 CCE, okay. So, one second, and we'll begin at control channel element 0, okay. And what is one control, how many control channel element, what is the definition of control channel element? It contains 6 REGs, okay, right. So, what are we saying here? This is 1 CC, this is second CC, that is how it continues, okay. Underneath this there are 6 REGs which are sitting together, okay. So, what are we saying here? If the aggregation level of 1, this can, so at aggregation level 1 you can begin from any location, you can location 0, 1, 2, 3, 4, okay, right. If it is aggregation level 2, so you will begin only at, because you are aggregating 2 CCs, right, okay. So you will begin from this, correct. If it is aggregation level 4, where will you begin? From here, you will begin from here, you will begin from here, you will begin from here. If it is aggregation level 8, you can begin at only at these locations, okay. Is this clear what are we saying here? So this is, each one of them is a CC, right, okay. So because here at aggregation level 1 you are not aggregating any CC, you can begin from any location. Here you are beginning from, you are aggregating 2 CCs, so you will begin at every even location, okay. And that is the point I made earlier wherein I said that CC at aggregation level 2 cannot begin from here, right, it will begin only at even location. Similarly, aggregation level 4, it will begin at every 4th location, right, at aggregation, and so on for aggregation level 8, right, okay. And why are you imposing this restriction? Why are you not beginning from here for CC, for aggregation level 2, okay. So if you do not impose this structure, of course, like you saw that for this, for user 1, right, it will have to make many more attempts, right, because then you are sliding over it, correct. Otherwise, what it will do, it knows that at aggregation level 2, the PDCCH can come either here or here or here, but not here. So it does not have to slide and search like this. It only hops and searches, correct, okay. So this is the restriction which I was talking about, and why this restriction is imposed, so that the number of blind decoding attempts can be restricted, right, okay. Just to give you an example, for this user, okay, the search space is defined like this, okay. This is a UE1, a particular UE search space. What are we saying here? At aggregation level 1, the DCI or the PDCCH of this user can come in any of these locations. At aggregation level 2, it can come at these locations. At aggregation level 4, it can come at these locations. At aggregation level 8, it can come at these locations. So this search space is defined for a particular user, right? Okay, and we saw that how will it search, okay. So let us say it has received all this particular symbol, okay, correct, and this is actually one symbol only, right, okay. What are we saying here? In the same symbol, okay, at aggregation level 1, the search space is defined here for this particular user. At aggregation level 2, in the same symbol, it is defined here, right, okay. Similarly, over here and over here, this is essentially the same symbol, okay. I am showing you different aggregation level search spaces. You understand what am I saying here, okay. So what will a user do? In the same symbol, okay, it will start searching from here at aggregation level 1. If it is PDCCH is coming here, it will basically be fine, okay, right, if it has been told to monitor only one, otherwise it will have to monitor other also, correct, and that is the point I was making here, okay. It can monitor up to 4 different DCIs, right, okay. So let us say it is able to find 1 over at aggregation level 1, if it has been told that it has to monitor 4, it will search other search spaces also, right, okay. So at aggregation level 1, it searches from here. At aggregation level 2, in the same symbol, it has been told explicitly. So it will search this, search this, search this, and go on like that, okay, right. And similarly at aggregation level 8, CORESET containing PDCCH candidate with aggregation level 8 begins only at CC location multiple of 8. That is what I am saying over here, okay, right. So, and they are PDCCH candidates, as I said, okay. This is one candidate location, this is another candidate location, and it will search. If it finds, it's okay. If not, then it moves on, okay, right. So requiring a UE to monitor all possible CC aggregation will still make PDCCH detection complex. What is this bullet saying? I am defining only specific search spaces. I am not saying that please search in all these locations. Okay, if a UE has to search at aggregation level 1 at all these places, gone. And like, let's say how many are 38 are there, right? Okay, okay. So it will have to make 38 attempts right here itself. It will not be able to monitor at any other aggregation level, right? Okay. So what is it told is, okay, please monitor these candidates at aggregation level 1, monitor these candidates at other aggregation level, these candidates at another aggregation level, this at another aggregation level, so that the maximum number of attempts is 36. Correct? Okay. Otherwise, it can go on forever. That's the CORESET restriction I was talking about. Okay. And why different aggregation level? Because as I said, its SNR may fluctuate if it moves. Right? Okay. So, and if it has to monitor all these candidate search spaces, it will need definitely more than 36 attempts. And I am showing you one example. Right? Otherwise, like 1, 2, 3, 4, 5, 6 only. We are telling it monitor 6 candidate search spaces at aggregate level 1. Right? Okay. So that's what it is. To limit the maximum number of blind decoding attempts in the device, NR defines search spaces. That's the term we have been using. Okay. But we'll go further and we'll discuss what kind of search spaces standard defines. Okay. And you see the name, it is coming as UE specific, and it essentially tells us that this search space is specific to a user. Okay, right? So I've taken two examples. This search space is defined for device A, this search space is defined for device B. Okay, and what is, you look at, we'll discuss this. Okay, so a search space, as I said, is a set of CCs at a given aggregation level in a CORESET which UE is supposed to monitor to decode PDCCH. As I said, at aggregation level 1, this is the example we took. I've told you before this has come in English, I told you verbally. Okay, so this is basically, this is the search space at aggregation level 1 for UEA. This is the search space at aggregation level 2. This is the search space at aggregation level 4 for UEA. Similarly, these kind of search spaces are defined for UEB. This is the same symbol, by the way. Have that picture clear in your mind. Okay, they are not different symbols or different source grids. I am talking about symbol 0, right? Okay, so the pictures are being shown such that the notion of aggregation level is clear to us. Okay, please be clear about that. Okay, otherwise you can say, okay, 4 different symbols, 4 different aggregation spaces, aggregation levels. No, I'm not talking about that. And different UEs, different resource grids. No, it's defined in the same symbol in the same resource grid. Correct? Okay. So, for example, search space of UEA, what are we saying here? At aggregation level 1, it consists from 22 to 27. We have seen that already, this is written here. At aggregation level 2, it consists from 66 to 70. At aggregation level 3, it is from 28 to 35, and at aggregation level 4, it is from CCE to 16 to 31. So each one of that is a CCE control channel element. So granularity here is, and the last slide is, each of this box shows a control channel element. Okay, right? So similarly, this CORESET, as I said, okay, the control resource set is shared by multiple users. So this symbol is used as a CORESET for another user also. Okay, right? And what am I saying here? Look at this. At aggregation level 1, okay, I have offset is from here. Okay, right? For user, for device B, okay, this is the search space at aggregation level 1, at aggregation level 2, at aggregation level 4, and aggregation level 8. Okay. Of course, there are these questions. We'll see there are certain things are happening over here. So UE, just for example, these are 2 different search spaces. Okay, for 2 different UEs. What are we saying here? UEA cannot be addressed on a PDCCH starting at CCE number 20, whereas UEB can. Okay, so where is CCE level 20? Okay, right? You see this. UEA cannot be addressed over here, whereas UEB can be addressed at what aggregation level? Aggregation level 4. Right? So this has been indicated to this user. So UEA will not search at aggregation level 4, right? For this at aggregation level 4. Okay. Right? Even at aggregation level 1 it will not search because aggregation level 1 search space is beginning at 22. right? That's the point this bullet is making over here, correct? Okay, right? Let's continue discussing this. What are we saying here? Okay, look at it in more detail. So UE A is using CCE 16 to 23, right? Okay, correct. Device B cannot be addressed on aggregation level 4 at these 16 to 23. If, what am I saying here? Okay, right, that if UEA is using 16 to 23 at aggregation level 8, okay, this includes 16 to 23 is included as search space for UEB also at aggregation level 4. Okay, let's say user has assigned this, so the base station has assigned this CCEs to this user. What it will do? Then it will not assign these CCEs to this user at aggregation level 4, because it has already assigned this. That's what this is, the point is being made here. Okay, because you cannot use the same location for two different users. Okay, but the search space includes that, right? And the UE doesn't know. You see this. Okay, so UE base station has mapped, for example, data DCI of user A from 16 to 23, which is aggregation level 8, right? UE doesn't know that, correct? What will UE do? UE will still search at aggregation level 4 at these CCEs also, but it will fail, right? Okay, because these CCEs at aggregation level 4 are included in its search space. Similarly, they are included at aggregation level 1 also. It will search there, but it is going to fail, right? So what are we saying here? CCEs in its level 4 search space are blocked for UEA, because that's what UEA data at aggregation level 8 are being transmitted. 4 it will not be, even at 1 it will not be, if it is, right, 16 and 17, because it is blocked for transmitting UEA data or UEA DCI, right? Okay, that's how base station has to do the mapping. Okay, and since these search spaces are defined, we'll have to search accordingly. Okay, it's in the same symbol. Okay, so and CC is forming a CORESET for UE also varies as a function of time. This is not fixed. That's the point I'm trying to make. Okay, because just for example, okay, the channel at all these CC is bad. Okay, why will base station use these CCs for user A? It'll move on. It'll allocate some other CCs where the channel is good for this particular user. So it is dynamic across slots. Okay, but it is indicated, okay, that for these many slots your configuration is going to remain constant. That signaling happens at other level, but what am I telling you here is this will change, this can change along with time. And the reason is because the channel is changing, right? Okay, and another is to avoid two devices constantly blocking each other, right? Just for example, okay, if I use this, right, at aggregation level 8 continuously for UEA, I cannot use it at these locations, this locations at aggregation level 4 for UEB. It's continuously blocked, and UEB needs that kind of data, right? It needs aggregation level 4, right? Then you are blocking this. You will not be able to transmit data for device B at these CCEs, right? So you have to basically change it. Base station can figure out, of course base station is only assigning, then it can move it later. But if device B doesn't need aggregation level 4, it needs only aggregation level 1, there is no need to change for the time, okay, right? So, and it's happening, okay, if they collide at one time instant, they are not likely to collide at the next time instant. If they continuously collide, then you change it. If they don't collide, which I gave you an example just now. In this case, if aggregation level 1, they will not mostly collide, right? Okay. For efficient utilization of the CC, search space should differ between devices, and that's how we have defined. There are different search spaces, correct? If I define the same search space for this user, right? Of course, like if I'm sending one CC for this user, there are, let's say 10, I've defined it for 10 different users, then you're going to block some of them, right? If the same search space is being defined. That's the point I'm making here, that if to be efficient, the search spaces should be different for different users so that they don't block each other, okay, right? So, and don't forget, so what does this mean? These are UE specific search spaces, correct? They are defined specifically for each user. These search spaces are defined specifically for each user, okay, right? And to put things in perspective, if this is, we are calling as UE specific, there's something called common search space that we'll see later, okay, right? So this is what am I saying here? Each UE has one or more UE specific search spaces configured consisting of multiple core sets. That's what I showed you here. Okay, and look at this. Okay, so this is again along time. I'm showing how it is evolving. Okay, right. So CORESET with search spaces for aggregation level 2. This is one slot. Okay, right. And so what are we saying here? No monitoring in this occasion in this search space. Okay, right. But they are being monitored at aggregation level 4, but this is not being monitored by this user. Similarly here in this slot, what we have said, okay, this user will monitor this search space. It is evolving over time. This search space, it is again not monitoring there. Okay, right. So you can, that's the point we made, that this search spaces can change dynamically over time. Okay, and they are changing. They are not monitoring, UE is not monitoring here, but monitoring here. Again, not monitoring here. But this is being continuously monitored at aggregation level 2. At aggregation level 4, sometime it is being monitored, sometime it is not being monitored. Okay, and to be clear, UE knows the location of these UE specific search spaces. Okay, right. How is it known? Let's leave it at this, because some other signaling is required for that. Okay, and how is it defined? Okay, right. When a user is like trying to enter the network, as we discussed in some form, a user is given this identity. Okay, this is a unique identity, radio network transmitter identifier. Okay, so C is, I think, central or something. Okay, so CRNTI. So in each of these search spaces, UE attempts to decode PDCCH using UE specific CRNTI. Okay, and how this CRNTI is used? Scrambler, right? Otherwise there is no other information. Correct? And this successful decoding attempt, what does that mean? It has to basically validate that scrambling. Okay, right? So if valid control PDCCH is found, UE acts accordingly. It knows where its data is coming, and it will basically decode its PDCCH after that. Okay, so so this is broadly the UE specific search space is defined. We need to discuss this common search space. Okay, we'll discuss that in the next class, and then it'll bring us to the end of this CORESET discussion. Okay, then I'll take an end-to-end example, okay, of like PDCCH generation, mapping, and then what happens after that. Okay, so we'll stop here. We'll discuss remaining part of the CORESET discussion, which is very short, in the next class. Thank you.